Melde's experiment. It is used to demonstrate a stationary wave in a stressed string using a large electrically oscillating tuning fork. There are two situations. First situation, when there is transverse mode of oscillation in tuning fork. If we see 4 loops are formed in a string, that means frequency of tuning fork is 4 times the fundamental frequency of a string. Now if we slightly increase the frequency of the tuning fork, then we all know wave will start damping out and no loops are formed. Now if we further increase the frequency of the tuning fork, then there is formation of the 5 loops, means frequency of the tuning fork is matching with 5th harmonic of the clamped string. In this way we see the resonance. Now if a string vibrates in P loop, frequency of string oscillation equal to frequency of the tuning fork, frequency of the string equal to frequency of the fork, and number of loops are, and there are P loops, so we will say P by 2L root T upon mu. So in the transverse wave we can say frequency of the vibration of tuning fork equal to frequency of vibration of the thread. Now we will discuss regarding the longitudinal mode of oscillation in tuning fork. Means we have to get the relation between frequency of the oscillation of the string and frequency of the oscillation of tuning fork. We all know when this tuning fork is like this initially, and when the arms are going away like this, in this situation, this is going toward this side, this is going toward this side, you can say the string will slack, there is slack in the string like this. And when arms are coming close like this, string becomes tight. Again when arms are moving away, string becomes loose and move in the upward direction like this. So in tuning fork, if we say 1 second 2 oscillation, means frequency of the tuning fork is given by 2. But in string, 1 second only 1 oscillation. It means frequency of the string is given to us 1. So frequency of the oscillation of the string is half the frequency of oscillation of tuning fork. So if I say string oscillates in P loops, then frequency of the string that can be written as the P upon 2L root T upon mu, and frequency of the tuning fork, we all know frequency of the string is given by half frequency of the fork. So frequency of the fork can be written as 2 times frequency of the string. So we use this formula, we will get P upon L root T by mu. So in transverse mode of vibration, frequency of the tuning fork is exactly equal to frequency of the vibration of the thread. But in longitudinal mode of vibration, frequency of the tuning fork is 2 times frequency of vibration of thread.